Okay, so we're back. Now, this is part 2 of the bike race problem. So if we remember, we have our biker who started at the start line, time 0 seconds. 0 seconds. He rode his bike 10 meters in 10 seconds and then stopped for 10 seconds. So he went 10 meters in 10 seconds. He then paused for 10 seconds. Then in the first part of this problem, he rode his bike back. Now, let's go back and check out the new question. So the next race our biker did. The next race he did everything the same, but after his pause he rode to the finish line, which was 10 meters away, in 30 seconds. So now he did everything the same, which means he started, he went 10 meters in 10 seconds, distance and a time. He paused for 10 seconds. Now while he paused, we didn't write it last time, but he went 0 meters. He did not go anywhere. But now, instead of going back, he's going to keep going, and he's going to go to the finish line. Now, the finish line, it says, is 10 meters away, and it takes him 30 seconds to get there. So now our young bike rider started here, rode here in 10 seconds, took a 10-second pause, rode to the finish line in 30 seconds. He left the start line, went 10 meters, paused, going 0 meters, and then went to the finish line 10 meters away. So let's put this on a table. So his start time is still 0 seconds. Time to his midpoint, which is where he took his pause, is 10 seconds. The time of the pause was 10 seconds. The time to the finish was 30 seconds. And the distance that the finish was away from the pause is 10 meters. Now we are going to graph. So let's make it so we can see both. Perfect. All right. His start time is 0. And now this beginning graph is going to look a lot like the one on the other page. His start time is 0, and it took him 10 seconds to ride. So we're going to move over 10 seconds on our y-axis, our x-axis, I'm sorry. Then, how far did he go? Well, he went 10 meters to the midpoint. So we're going to put a dot at 10 seconds and 10 meters, his midpoint. We're going to connect this with a line. Now, what did he do next? Well, he paused for 10 seconds. Now, while he paused, he went nowhere. So we're not moving our line. It's going to be flat. And his 10-second pause is going to go from 10 seconds to 20 seconds. We'll put a dot. 10 seconds of rest. He didn't go anywhere. Now, it's going to take him another 30 seconds to finish. So we know our finish line is up here at 10 meters away. It's going to take him 30 seconds. So let's start at 20 and move over 30 seconds. So we got 10, 20, 30 seconds. So we are going to be on the 50 on the x-axis. And how far is he going from his pause? Well, he's going 10 meters up. So 10 meters from here, from at 10, is going to be 20. So I'm going to be at 50 on the x and 20 on the y. I'll connect these points. And now my graph tells a different story. It says that he left at 0, went 10 meters, took a 10-second break. This is a straight line because he did not go anywhere. Then he left at 20 seconds and went to 20 meters, and it took him a time of 30 seconds to get there. So when he ended up here, it was 50 seconds into the race, and he went 20 meters away. Now let's find our distance. How far is this point from our starting line? So we add 10 meters. Plus the rest, he went no meters, plus another 10 meters. So his distance is 20 meters. Now his displacement, how far did he end up from the starting line? Well, if he started here and he ended up here, that is a displacement of 20 meters to the right, or 20 meters away. So in this one, his displacement was 20 meters, And his distance, oops, sorry, I said the distance was 20, but I wrote 10. So his distance was 20 meters because he went 10 plus 0 plus 10 meters, giving us 20 meters. His displacement was also 20 to the right because he ended up 20 meters away from where he started from. Now that is different than the displacement on the first one, where he went back to his finish line. So he actually had a displacement on that one of 0 meters. Now, these are both the situations that you worked on and found data for on Friday when we were running the race course. So now you're going to use this to finish crunching your numbers and coming up with your distance graphs for your data.